Jerry went for a ride in his bike. He moved from A to B, that is a distance of 30 kilometers, in 1 hour. He went from B to C, which was another distance of 30 kilometers, in 2 hours. Again, he went from C to D, which was a distance of 20 kilometers, in 1 hour. So what is the speed of Jerry? Let us calculate the speed of Jerry in the 3 stretches. In going from A to B, Jerry covered a distance of 30 kilometers and the time taken by Jerry was 1 hour. We know speed is equal to distance divided by time. So speed of Jerry in this stretch is 30 kilometers per hour. Now what about the speed of Jerry in B to C? In B to C, Jerry covered a distance of 30 kilometers and the time taken by Jerry was 2 hours. So he covered 30 kilometers in 2 hours. So what is his speed? Speed is 30 by 2, that is 15 kilometers per hour. And what about stretch C to D? In C to D, Jerry covered 20 kilometers in 1 hour and speed is 20 by 1, that is 20 kilometers per hour. So these are the 3 speeds of Jerry in the 3 stretches A to B, B to C and C to D. So what if I ask you, what was the speed of Jerry over the course of the entire journey? That is from A to D. Which of these speeds would you choose? Because each of these speed is different. So will you say 30 or will you say 15 or will you say 20? Well, the answer is actually none of these. Because if we want to calculate the speed for the entire journey, we want to calculate the average speed of Jerry. And the average speed is given by total distance traveled divided by total time taken. We had seen that the total distance traveled by Jerry was 30 plus 20, that is 80 kilometers. Total time taken was 1 hour plus 2 hours plus 1 hour, that is 4 hours. So the average speed of Jerry for the entire journey was 80 kilometers divided by 4 hours, that is 20 kilometers per hour. Now, can we get this average speed by taking the average of 3 speeds which we had calculated earlier? So what do we get if we take the average of these 3 speeds? Do we get the average speed? Let's see. So we know for taking average, we sum up the quantities and divide by the number of quantities, which is 3 here. The unit should always be mentioned. It is kilometer per hour. This gives us 30 plus 15 is 45 plus 20 is 65. 65 by 3, which is equal to 21.67 kilometer per hour. We had calculated the average speed as 20 kilometer per hour. And we see that this average of 3 speeds is not equal to the average speed. So what do we conclude? We conclude that average speed is not the average of the speeds. So what is actually average speed? Well, when we prefix average to any quantity, we assume that the quantity is uniformly distributed throughout. So when we say average speed, we mean that the distance traveled is distributed uniformly over the time intervals. So let us see what would happen if Jerry would actually have traveled with his average speed throughout the journey? That is, Jerry would have traveled with the average speed of 20 km per hour and covered the same distance. So for covering the same distance at 20 km per hour in the stretch A to B, that is for covering 30 kilometers in 20 km per hour, time taken would be distance by speed, which is 1.5 hours. What would be the case for B to C? 30 kilometers is the distance, speed is 20 kilometers per hour. So again, time taken will be 1.5 hours. It is the same as this case. And what would be the case for C to D? 20 kilometers is the distance and speed is 20 kilometers per hour. So the time taken will be 1 hour. So what is the total time taken? 1.5 hour plus 1.5 hour, that is 3 hours, plus 1 hour, that is 4 hours. And initially also, the total time taken by him was 4 hours. So again, he's covering the same total distance in the same total time. So in essence, average speed is the speed with which the body travels if its speed were constant throughout. That is, if it was moving with a uniform speed, then the body would travel with the average speed. However, this is not the case with most of the objects in real life. That is, their speed does not remain constant over the time. So we come to the concept of instantaneous speed. So the speed of a body at any instant is called the instantaneous speed. So when we say average, we are talking about a time period. So that time period can be 1 minute, 1 hour, 20 hours, whatever. But when we say instantaneous, we mean a specific moment, a particular moment in time. And in case of a body moving with uniform speed, the instantaneous speed is always equal to the average speed. We have already studied that average speed is the speed with which the body will travel if it has uniform speed. So if a body travels with uniform speed, the instantaneous speed will always be equal to the average speed. Now observe this. Jerry leaves his hole, goes to 200 meters, has cheese, meets his friend at 300 meters, comes back at 150 meters, does a mischief and returns to his hole. So this is what we get. At 0 seconds, he was in his hole. At 10 seconds, he was here at 200 meters. At 20 seconds, he was here at 300 meters. At 35 seconds, he came back to 150 meters. And at 40 seconds, he went back to his hole. So this table gives us the position vector of Jerry at different points in time. So this is a position vector. It denotes the position in meters and time in seconds. Given this, we can find out the displacement of Jerry in different time intervals. So in time interval 0 to 10 seconds, the displacement will be final position minus initial position. So final minus initial, that is 200 minus 0. So it will be 200 meters. In time interval 10 seconds to 20 seconds, the displacement will be final minus initial, that is 300 minus 200, 100 meters. In time interval 20 to 35 seconds, the displacement will be 150 minus 300, that is minus 150 meters. So this is negative displacement, indicating that he changed his direction, which we had seen in the video. In time interval 35 to 40 seconds, his displacement was 0 minus 150, that is minus 150 meters. So this table shows the time taken by Jerry and the displacement of Jerry. Now, what is the average velocity of Jerry for the entire journey? Average velocity is total displacement by total time. So, what is the total displacement of Jerry for the journey? Now, in 0 to 40 seconds, his initial position was at 0, his final position was at 0. So, total displacement is equal to 0 minus 0, that is 0. And time taken is 40 seconds. Therefore, average velocity for the entire journey was 0 meters per second. So, the average velocity of Jerry was 0 meters per second. However, it is obvious that Jerry was not traveling with a velocity of 0 meters per second throughout. He had some velocity, that is why he was moving. So, the velocity of a body at any instant is called the instantaneous velocity. So, at different stretches, say in this stretch, what is the velocity of Jerry? Well, displacement is 200 meters, time taken is 10 seconds. So, velocity is 20 meters per second. In this stretch, displacement is 100 meters, time taken is 10 seconds. So, velocity is 100 divided by 10, that is 10 meters per second. Similarly, we can calculate for the others. So, what is the velocity of Jerry at the 5th second? At the 5th second, velocity of Jerry is 20 meters per second. So, this is the instantaneous velocity of Jerry at the 5th second. And in case of a body moving with uniform velocity, the instantaneous velocity is always equal to the average velocity. So, we have seen that if total displacement is 0, the average velocity is 0. If total displacement is negative, the average velocity will be negative because time taken cannot be negative. However, speed is never negative. So, let us answer a question here. What does the speedometer of a car measure? Well, what does the speedometer of a car measure? Does it tell you the direction? Does it tell you anything about the direction? No. So, velocity is out of question. So, does it tell you the average speed or instantaneous speed? Well, we see that it keeps on moving and the speed which it shows keeps on changing as the car moves. So, it tells us the speed of a car at different instants of time. Hence, it tells us the instantaneous speed. The speedometer of a car tells us the instantaneous speed.